Okay, so we're going to talk about solving equations of the sort um, a linear equation and then an inverse equation. What we want to do when we solve these is we want to find where they intersect. All right, so with that, we are going to find the intersecting point, and you can do that by several ways. First, you could use a table, you could use a graph, and you can think about just where is it reasonable to think that these would intersect. Now, this is a kind of a large equation. This one is talking about a linear equation, and we're talking about supply and demand here. And supply and demand is an economic kind of, well, it is an economic situation, but it's important. It's got a lot of math background, so those of you that are in economics can relate to all the math that's involved. All right, so this would be our linear part of our equation, the 0.1x, and this would be our inverse part of the equation. So what we want to think about is where would these two intersect? Again, we would use tables, and that's just setting up a table for the linear part. And if I put 1 in here, I would get 0.01 and so on. And then setting up a table for the demand part. And if I put 1 into this one, I would get 200,000. And if I put 2, I would get 100,000. And just to see where they would intersect. Now, one thing that it's reasonable to think about, that if I were to use a table in this situation, it would be hard to come up with that answer right away. Okay, you would have to be using some large X values. Graphing is another way. This one you can either use a graphing calculator or you could use Desmos, and all you would do is put this into the 0.1 X into one box, and in the other box you would put the 200,000 divided by X into the second box, and you would find out where these two things crossed. Again, think about what is reasonable, what is easiest for you to do. Okay, so the first thing that we're going to think about is we have our linear equation and our inverse. Remember what these are. Oops, linear and inverse. Okay, and you can graph this. Okay, pretty easy to graph. I don't know. I'm going to see if I can bring up my calculator. Maybe I can. All right, hopefully you can see this. And what we're going to do, I'm going to move this over, is we're going to we're going to go to our y equals. First, I'm going to clear out anything that's in there. And I'm going to put this part right there, oops, it disappeared, into my y1, so 1.5x. And then I'm going to go down to y2. And I'm going to do 6 divided by x. All right, and then I'm going to do a zoom 6, which is just a standard window, 10 by 10. And there's our first one. And there's our second. Now, first off, what you want to think about is these have two intersecting points, correct? If this is a supply and demand kind of situation, it's logical to think about two because of this. The inverse equation is always going to have two. You're going to have two parts to it because you're going to have that asymptote. But with a supply and demand equation, basically what you're looking at is just, I guess we can move this over. Hold on, so that we can see this better. You're looking at just this part right there. Okay, that intersecting point. This intersecting point in a supply and demand isn't going to really make any sense, but from a math perspective, we have two intersecting points. All right, there are two. One is in the positive or the first quadrant, and one is in the negative negative or the third quadrant. Okay, so that's if you graph it. And you can use a graphing calculator, or again, you can use Desmos. Either one will work. All right, that's pretty cool. Okay, so let's get rid of that. So that's how you would graph it. And again, to think that it's going to have two um, solutions, right? One positive and one negative. Now, when in the context of the problem that you're thinking about, the reasoning part is going to come in when you're thinking about your answers. Isn't it reasonable to have a negative answer? Is it reasonable to have a positive answer? This is where you actually think about what you've done. You don't have to do any math, you just think, does it make sense? Does it make any sense to have a negative answer? All right, so that is graphing. Let's do a table. So now we have negative 2x is equal to negative 18x. And if I put that in there, I can see that we have, if I put 0 in, now I can't put 0 in here. Because if I did, if you think about that graph that we had before, this is not going to be a very good one, but what you're going to see is that right along this line, the y-axis, you're going to have that, oops, and I think this is going to go this way. Yeah. 3 negative, yeah. Okay, right along that y-axis, you're going to have a vertical asymptote because you cannot divide by 0. So let's put in some number. We put in 0. 0 is never negative or positive, so this doesn't matter. Into the first one, we got 0. We put 1, we got negative 2. We put 3, we got negative 6. We put 4, we got negative 8. So let's just put in a negative 3, and we'll get a positive 6 here. And then, excuse me, if we put in a negative 3 here, we also get a positive 6 here. So again, we have two intersecting points. Okay, and let me just write this, intersection. Okay, and an intersection. Okay, so we have two intersecting points, which is reasonable to think about because of this second graph. It's got that vertical asymptote, and there's two parts to it. This graph is going to go, oh, probably something like this. All right. And so we have those two intersecting points. Now, just for fun, and because I can, I'm going to graph it. So let's go back to our y equals. We're going to clear this one. Going to go down. We're going to clear that one. And we're going to say negative 2x. And then we're going to go down here. We're going to say negative 18 divided by x. And let's just graph. Okay, so the two intersecting points, 1, 2, 3, yeah, y was 6, x is negative 3, y is 3, x is negative 6. Okay, the other way that we can find intersecting points, and you don't have to do this, it's just because, you know, some of us like to have fun. We can go to second calc, and we can go down to number 5. And it says first curve, yes, so we press enter. Second curve, yes, and where it says second curve, this up here is the second curve. Say yes. And then, oops, second curve. Up there. Yes. Wait, it's not working for me. Okay, never mind. This is a trial thing, so sorry about that, guys. Okay, but you can do it on the calculator too. All right, so that's that. Now let's see if we can graph it by hand. We're going to graph a different one. Now we're going to graph x plus 1 and 6 divided by x. So again, if you're graphing by hand, which is, you know, fun to do. So if x is 0, you really, I don't know, you can use 0, you don't have to. Negative 1, x is 1, y is 0, x is 2, y is 1, x is negative 1, y is negative 2, x is negative 3, y is negative 4. So let's graph. 0, x is 0, y is negative 1, which makes sense. That's the y-intercept. X is 1, y is 0, up 1 over 1, up 1 over 1, right? So there's our hold on, I want to make a straight line. See if I can do this. Ta-da. Okay, so there's our straight line. This is x minus 1. Now for our other one, let's just do that one. This is x and this is y. So we can't divide by x. So if x is 1, y is 6, x is 2, y is 3, x is 3, y is 2. X is, trying to make even numbers, 6, y is 1. Negative 1, we get negative 6. Negative 2, we get negative 3. Negative 6, we get negative 1. Okay, so if x is 1, y is 6, 6. X is 2, y is 3, 3. X is 3, y is 2. X is 6, y is 1. Okay, so I'm going to try and draw this. Here is our first. And let's do the other one. X is negative 1. Right here. Negative 2. Right here. Negative 6. Right here. Okay, and then this one. Go up. So here we see that our intersecting points are where, again, x is equal to negative 2, y is equal to negative 3, and up here, x equal 2, y equal 3. Those are our intersecting points. So for this first part, you're going to have a couple questions just about graphing. You can either graph or using Desmos, you can use your own, just use a piece of graph paper. You can use tables. You can solve it however you want. But I want you to think about the reasonableness of this. Okay, and for our last, there'll be a couple like this. Now there'll be also, let's think about a different kind. Let's use the same equation. So what if you just really, really, really want, okay, you don't want to graph, you don't want to think about the reasonableness, you don't want to think about the table. Let's just solve this for x. So the first thing that you would do is you would try to get rid of this in the denominator, because when we solve things, we don't like to have fractions. So since this is being divided over here, what we're going to do over here is we're going to multiply each side by x. All right, good job. Now what we're going to do is we're going to distribute. Now, we've all done factoring. We just got done with factoring. So we want to set this equal to 0. So, oops, sorry, let's subtract 6 from both sides. All right, now we're going to see, do we have factors of negative 6 that are going to add up? You can say sum, you can say add, to negative 1. So we're going to write down all the factors of negative 6. I think that's it. And which of these add up to -1? Well, right there. So it's x minus 3, x plus 2. So set those equal to 0. Oops, that should be -3. So let's add 3 to both sides. I forget about doing this. X is either 3 or, oops, subtract 2. So they intersect where x is 3 and y is -2. And if we go back, oops, sorry, that's the wrong one. There we go. If we go back to here, we have x is 2. This should be 3. Oh my gosh, you guys. Sorry. And this is -2. Okay, so you've got 3 choices. You can either do a table, you can do a graph by hand or in Desmos or on a calculator, or you can solve this algebraically. So whatever choice you want to do, that's what you do. And then you go on to your practice. Excellent.